Hello, friends. Welcome to another topic, which is absolutely very significant in terms of your CAT in MATSNAP IFT kind of exam. So, any MBA entrance exam you go, you encounter this topic invariably. So, we have done arithmetic, we have done more maximum part of algebra. Now, what we are venturing into is possibly one of independently huge area. You will typically see 2 to 3 questions, at least 3 questions you can expect in CAT, and similarly EEE in MATSNAP IFT. So the topic that we are going to start today is on number system. Okay. So number system is one of the most important area, or arithmetic has the highest number of questions, followed by algebra or sometime number system. So you will see it's a vast area. There are a lot of concepts that needs to be covered in number system. So that's why we first built the base with arithmetic and algebra, and now we are typically focusing on the number system. Now, if you see typically number system, there are, like I said, there are a lot of concepts that needs to be covered in number system. But what we'll do, we will create a series of small videos so that you understand each of these concepts well. We'll solve a few of the example problems and establish the concepts. Once we solve most of the concepts, we will have 2 to 3 deep dive problem solving session of number system. So in today's session, so we will have series of concept videos first, along with few examples that will help you understand the concepts much more clearly. Once that is done, we will typically focus on at least 3 sessions on typical problem solving of number system, because most of the number system problem you need to understand the entirety of the number system. What are the different type of problem that can different type of concepts are there. But once everything is in place, we will deep dive on the problems. So typically 1+2, or 1 session on fundamental and 2 sessions on problem solving, like we have done till now in arithmetic and algebra. We will not follow that approach because this is a different area, it needs a different kind of approach. We will do this series of videos on concepts and examples, and then do a deep diving session on problems. So that's clear. So today is the first session of number system, and what we will cover here is, there are 2 topics that we are going to cover today. Is the classification of numbers, and the second topic that we are going to cover today is the divisibility rules. Okay. So at a high level, these are the 2 things that we are going to cover in today's session: classification of numbers and divisibility rules. So let's start with classification of numbers. So this is the most foundational block of number system, or your entire mathematics, I'll say. So there are 3 type of numbers that are available, which is basically taking the same numbers, all 0 to 100, or we know the set of numbers, but there are primarily 3 type of numbers. I say first is a set of natural number. Now, what is the natural numbers? The natural numbers are the set that starts from 1, 2, 3, goes till infinity. Okay. Yeah. So this is the set of natural number. Now the next one is the set of whole numbers. So what are the whole numbers? The whole numbers is the same set of natural numbers along with 0, 0, 1, 2, 3, and goes till infinity. Right? Now, the next part is on the integers. What we say as integers? Integers are your minus infinity to minus 2, minus 1, 0, 1, 2, and goes till infinity. So this is basically the integers. So you have a negative side and you have a positive side. So these are called as integers. So these are the primarily 3 type of numbers that we are going to focus about: natural number, whole number, and integers. Now, integer out of that is basically the most commonly asked or used type of numbers that you will see in the problems. So for example, let's say there is a problem, right? X square equal to 2x. Okay, this is given, and they said find x is what if, let's say, x is an integer. Okay, if x is an integer, from here we can say x square is 2x. So x is equal to 2 or x is equal to 0. These are the only two possibilities, right? So if x is an integer, then x will be equal to 0 or 2, right? If x is an integer, x will be 0 or 2 because both 0 and 2 are your integers. Now let's tweak this problem a little. What if I tell you the same problem, but x is a non-positive integer? Okay, see change in the problem. So previously I was saying x is an integer which does not have any condition to it. Now I'm saying x is an integer, but a non-positive integer. If it is a non-positive integer, so then x can only be 0, because when someone say non-positive, that means it is 0 and minus. Okay. Now, if someone says non-negative, then it starts from 0 and it moves on, right? So I understand this non-positive numbers. So basically, I'm trying to say non-positive should include 0, -1, -2, and so on. Similarly, non-negative will have 0, 1, 2, and so on. Okay. So this is the difference between a non-positive and non-negative. Okay. Now, the same problem, let's say they have asked x is positive integer. If they said x is positive integer, so when we say x is positive, x can only take one value, that is x equal to 2. So what we understood from here, so within integer, if someone says non-positive, we know it's 0, -1, -2, so on. If someone says non-negative, it is 0, 1, 2, and so on. If someone says positive, it's 1, 2, and so on. If someone says negative, then it's -1, -2, and so on. So 0 is neither positive nor negative integer. So this is the most important understanding from integers. So 0 is neither a positive nor a negative. So you will include 0 if they have asked for non-positive or non-negative integer. If they ask for what are the integers, then you can include 0. If they ask what are the non-positive integers, you can include 0. If they ask what is the non-negative integers, you can include 0. But if they ask what are the positive integers, you cannot include 0. If they ask what are the negative integers, you will not able to include 0, because 0 is neither positive nor negative. So this is a very, very important understanding when it comes to the first set of things, that what are the whole numbers, natural numbers, and integers. Don't get confused between natural and whole. Just understand whole number will have 0, natural number will not have 0. Okay. Okay. Now let's move on to the next topic. With that, let's move to the next important piece of your understanding, that is the rational numbers. Okay. So what are the rational numbers? So a rational number is a number which can be expressed in P by Q format, where P and Q are integers and Q not equal to 0. Okay. So P and so any number that can be represented in P by Q format where P and Q both are integers and Q not equal to 0. So let's say 5. 5 is a rational because 5 can be represented as 5 by 1. So P is 5, Q is 1, satisfies the condition of rational number. It is a rational number. Similarly, let's say another number, let's say 1.25. Okay. 1.25, it is also rational because I can write it as 125 by 100, right? So both 125 is P, 100 is Q, P by Q format, Q not equal to 0, perfectly rational number. What else can be a rational number? Let's say I put 0.333, so on. So this is a recurring number. So which is basically nothing but 1 by 3. So then this is also a rational number, right? So let's say you have a fraction 0.162, anything 0.162. So this is also can be written as 162 by 1000. So this is also a rational number. Okay. So any recurring number. So this is a recurring, and this is a terminating. What these are very two important part. So what is a recurring decimal? A recurring decimal when there is one number or a set of more than one numbers keep repeating itself in the same order. So 0.3333, these are recurring, and terminating is, let's say, 0.162. The number ends at the decimal ends at 0.162. So then this is a terminating number. So if there is a recurring or a terminating, this will be a rational number. So we can say if a number is either, or number, I will say decimal, if a decimal is either recurring or terminating, they are rational numbers. If a number is either recurring or terminating, by recurring I mean you can have 0.33333, or you can have 0.13131313, which is a recurring. There is a set of numbers which is keep recurring itself. So they may not be terminating, but they are recurring. But if you have, let's say 0.125, 0.234, these are not recurring, but they're terminating because the decimal ends there. Now let's say you have root 2. Now root 2 is 1.414 and it goes on. So this is neither recurring nor terminating. So there is no recurrence of any particular digit or any set of digits, and the fraction is also not getting ended. Similarly with root 3, similarly with root 5. So all these are typically non-recurring and non-terminating. If this is the case, then they are typically called as irrational numbers. So ideally, irrational numbers are those numbers which are not rational. So anything that is not rational are typically your irrational numbers. So numbers which are not rational, right? So those are called as irrational numbers. So for example, pi. Pi, we normally write it as 22 by 7, but that's a assumed expression of pi. The actual value of pi is 3.14 and so on. So it goes on. So pi is not a rational number. Pi is an irrational number. Don't get confused by this because this is a assumed value of pi, not the exact value of pi. The exact value of pi is this. Okay. So any number that cannot be represented in p by q format, or any decimal containing number which are non-recurring or non-terminating in nature, they are also irrational numbers. So hope you understand what is recurring, what is terminating, what is rational, what is irrational. Any doubt, please feel free to drop a note in the comment. We'll explain it further. Now, when we understand all this, now let me give you a simplistic view on how you can understand this whole classification of number system. So let's say this is a bigger box, and this is a set of real numbers. Okay, this is a set of real numbers. Now within that, there is a largest circle that for of rational numbers. Okay, or rational numbers. Within rational numbers, you have a smaller set which is of integers. Okay, within rational number, you have smaller set which is as integers. Within integers, you have a smaller set of whole numbers, right? Because integers can have positive, negative, and zero. Whole number will not be negative integers. It will be only zero and positive integers. Within whole number, you have a natural number. N is a natural numbers. Natural numbers means not having 0 and 1, 2, 3. So this is the Venn diagram you can understand. And outside of this entire circle lies the irrational number. So for example, I can give you an example, rational number, but not integer, whole, and natural. So for example, what will lie here is something like 1.25. Okay. What will lie in integer but not whole and negative number? So something like that will be -2. For example, whole number but not natural number, only option is 0, right? So there are certain examples. That's why these are classified like this. So rational number is the largest, most outer circle. Within that, there are a set of numbers which are integers. Within integers, there are a set of numbers which are whole numbers. Within whole number, there are a set of numbers which is natural numbers. And outside rational number, under the gamut of real numbers, is basically irrational numbers. Okay, so irrational number are typically √2, √3, pi, like we have seen. Okay, so hope you have understood the rational, irrational, integer, whole number, positive, negative integer. So these are very basic and fundamentals of your number system. Now let's move to another topic, which is on the even and odd numbers. Okay. See, the first part was very important to understand and have your basics crystal clear on what is natural, what is whole, what is integer, non-positive, non-negative, positive, negative, and rational, irrational kind of a number. Now, going a step further comes the even and odd number. Now, every one of us know what is an even number and what is an odd number, but I will not explain that. Any number that is divisible by 2 is basically an even, and the others are odd. Now, what we intended to focus on here is the relation between even and odd. So if there is an even and odd number gets added, your outcome will always be an odd number. For example, if you do a 3 plus 4, you get 7, which is an odd number. Similarly, if you do a even plus even, you will get an even number. You will get an odd plus odd, you will get an odd number. You can take any example and you will be able to see this. So 5 plus 7, it will be 12. Sorry, this will be an even number. Okay. So odd plus odd will be an even number. Even plus even will be an even number. Even plus odd is the only scenario when you get an odd number. The same rule applies for subtraction. It's the same for subtraction. Okay. Now, what if there are more than one number? What if there is even plus odd? So you can actually break it down further. First, two even will give you an even, and then even and odd will give you an odd, right? Similarly, if I have, let's say, even plus even plus even plus odd, in that case, first two will give me even. This and this even will give me even. Even plus odd will give me odd. Okay. Now, in the next case, if you have, let's say, even plus odd, which basically even plus even will give you even. Even plus this odd will give you odd. Odd plus this odd will give you even. So what we can generally say, and if you can derive from here, this is a derivation. So first, see the example 4. We have 2 even and 1 odd. Outcome is odd. We have 3 even and 1 odd. Outcome is still odd. So even number does not matter. If there is a odd number of odd numbers, you will get odd number. In the 6th example, we have 2 even but 2 odd. You will see you will get a even number. Similarly, if for another example, if I do even plus odd plus odd plus odd, you will see the outcome will be odd. So basically, this is a very important understanding. And this is the same will be applicable in the first, second, and third example also. So if there is odd number of odd numbers, your outcome will be odd. Even number of odd numbers, your outcome will be even. So basically, what I'm trying to say is, and listen to this very carefully, it does not matter how many even number you have in a summation or a subtraction. It depends on the how many odd numbers you have. So if you have odd number of odd numbers, like 1 odd numbers, 3 odd numbers, your outcome will be odd. If you have even number of odd numbers, the outcome will be even. See the first example, we have 1 even number, 1 odd number, outcome is odd. Second example, 0 odd numbers, so outcome will be even. Third, 2 odd numbers, outcome will still be even. If I have, so basically whenever there is a summation or a subtraction, always look for the how many odd numbers I have. So if I have even number of odd numbers, my outcome will be even. If I have odd number of odd numbers, outcome will be odd. So this is a very important understanding of even and odd numbers when it comes to sum and subtraction. Similarly, if I say, what if my for multiplication, what we can say is even into odd is all, sorry, even into odd is even. So let's say 2 into 5 is 10. We can say odd into odd is odd. So that is, let's say 3 into 7 is 21, for example. You have even into odd, even into even, that is also even. So let's say 4 into 6 is 24. Similarly, if you have even into odd, so again, you take the first two, this is even into odd is even. Similarly, if you have even into odd, so if you have 4 odds, you will see first one even into odd is even. Again, even into odd is even into odd is even into odd is even. So your outcome will be even. So basically, for multiplication, the standard rule is, if you have at least one even, outcome will be even. All odd only give you odd when it comes to multiplication. So for multiplication, the idea is, if you have at least one even number, then your outcome is going to be even, no matter how many odds you have. If you have only odd numbers, then only the outcome is odd. So from summation, the more power is with odd number. The number of odd numbers determines the outcome will be even or odd. In terms of multiplication, the power is with the even number. Even if there is one even number, the outcome will be always a or even number. If there is no even number and all odd numbers, then only the outcome will be a odd number. Okay. So with that, let's move to the next piece. Let's say prime numbers. Okay. We will do prime numbers. So what are the prime numbers? Prime numbers are those numbers which are divisible by 1 and the number itself only. So prime numbers are those numbers which cannot be divisible by any other number apart from 1 and that number itself. So for example, 5 is a prime number. Now what 5 is only divisible by 1 and 5. There's no other number that can divide 5 completely. Similarly, it's a 11. 11 is only divisible by 1 and 11. So the only even prime number is 2. And this is also the smallest prime. Okay. 1 is neither prime nor composite. So the antonym of prime number is composite numbers, where a number has factors or can be divided apart from 1 and that number. So for example, 4 is a composite number. 4 can be divided by 1, 2, and 4. So 2 is one number which can divide 4 apart from the number itself, which is 4 and 1. For example, 10. If I say 10, 10 is divisible, 10 can be divided by 1, 2, 5, and 10. So apart from 1 and 10, 2 and 5 are the numbers which can completely divide 10. So 10 is a composite number. 10 is not a prime number. So the smallest prime number and the only even prime number, which is 2. Every other even number you will find out will be divisible by 2 completely. So none of the other even numbers are actually prime numbers. Or 2 is the only even prime number which can be divided by 1 and 2. Okay. So 2 is the smallest prime. So 2, the next prime is 3, then 5, and so on. Okay. Now, 2 things you may want to remember. Between 1 to 50, there are 15 prime numbers. And between 1 to 100, there are 25 prime numbers. Okay. So this is something you may want to remember. Between 1 to 50, there are 15 prime numbers, and between 1 to 100, there are 25 prime numbers. Okay. Moving on. So if any prime number is more than 3, if any prime number is greater than 3, it can be represented as 6k plus minus 1. For example, and understand this very important, very nicely, that if a number, if a prime number is more than 3, they can be represented in 6k plus minus 1. But all the numbers that you can write in 6k plus minus 1 may or may not be a prime number. So all numbers which can be written as 6k plus minus 1 may or may not be prime. Okay. Now if you understand this, let's take an example. What I mean by these two statements, statement 1 and this statement 2. Okay. So let's say 11. 11 is prime. Now I can write 11 as 6 into 2 minus 1, which is complying with this format of 6k plus minus 1. 6 into 2 minus 1 is 11. So any prime number you take which is more than 3, they can be represented in a format of 6k plus minus 1. For example, let's take another prime number. Let's say 111. 111 is not prime. Let's say 101. 101. And in 101, you can write it as 6 into 17 minus 1. Any prime number you take, you will be able to write it in 6k plus or minus 1 format. But if I take 25, 25 is also written as 6 into 4 plus 1. But this is not a prime number because 25 can be divided by 5. So every number you can represent in 6k plus minus 1 is not a prime, but every prime number can be represented in 6k plus or minus 1 format. Okay. Now, based on that understanding, let's take a small problem. Let's say p plus 2, and p plus 4 all prime. Okay. Find how many values p can take. Okay, let's say this is the problem. They have given p plus 2, p plus 4, all of them are prime number. Find how many values p can take. Now, if p is prime, can I say p can be 2 or 3 or anything in 6k plus minus 1 format? Because what I know is if a prime number is more than 3, they can be represented in 6k plus or minus 1 format. Now, if p is 2, your p plus 2 becomes 4, so which is not prime. So p cannot be equal to 2. If p is 3, p plus 2 is 5, p plus 4 is 7. So all of these are prime numbers. All of these are prime numbers. So this is a valid scenario, p equal to 3. Now let's say p is any number which is 6k minus 1. P is 6k minus 1. So p plus p2 will be 6k plus 1, which can also be prime. And p plus 4 is 6k plus 3. Now, if you see this carefully, if I take 3 common, this is 2k plus 1. So this number is actually divisible by 3. This number is actually divisible by 3. So this is not possible because if p is 6k minus 1, p plus 4 cannot be a prime number. This number not prime. So p plus 4 cannot be a prime number. Similarly, if p is 6k plus 1, at p plus 2 only I get 6k plus 3. So this number is also not prime. So p can neither take 6k minus 1 nor it can take 6k plus 1. So the only value p can take is 3. So p can take only one value where p is equal to 3. Okay. So you understand how we can apply this. Now that's basically covers all the classification of number system that we wanted to cover. Now the important part you need to understand is the divisibility rules. So what we'll do, we will start from the divisibility rule of few of the basic numbers. So if a number is divisible by 2, the number has to be even. In order to be a number divisible by 2, the number has to be an even number. So for example, 4, 12, 1, 0, 2. So all these are divisible by 2 because they are even number. A number is divisible by 3 when sum of digits is divisible by 3. When sum of the digits are divisible by 3. So for example, let's say 126 is a number. So 1 plus 2 plus 6, that is 9. This is divisible by 3. Okay. Now let's take another example. Let's say 271. This number 2 plus 7 plus 1 is 10. So this is not divisible by 3. You divide 271 by 3, you see it is not completely divisible. But if you try with 126, you will see 126 is divisible by 3. Okay. So understanding and remembering these rules of divisibility is very, very critical. So 4, last 2 digit should be divisible by 4. So for example, if I say 126, the last 2 digit is 26. It's not divisible by 4 because 26 as a number is not divisible by 4. But if I say 224, last 2 digit is 24. So that means it is divisible. It is divisible by 4. To actually do 224 by 4, you will see you will get 56. If you do 126 by 4, you will not get a complete number. So 4, the condition is last 2 digit has to be divisible by 4. 5, we all know. Last digit is 0. Or 5. Yeah, last digit has to be 0 or 5. Then only the number is divisible by 5. Let's go to 6. 6 has to be divisible by 2 and 3. So you know the number for divisible by 2, the number has to be an even number, and for by 3, the sum has to be divisible by 3. So for example, let's say 216. 216, the last digit is even and it's an even number, so it's divisible by 2. So 2 is checked. Let's see for 3. It's 2 plus 1 plus 6, 9. So that means 3 is also checked. So 216 as a number, both divisible by 2 and 3. That's why it is divisible by 6. So that's the rule of 6. 7, I will come in a while. Just hold on for a minute. 8 is last 3 digit will be divisible by 8. Okay. So if someone says 1024 as a number, this is the last 3 digit 024. This is divisible by 8. So the number is whole divisible by 8. Someone says 2512. 512 is divisible by 8. So the number is also divisible by 8. Okay. So if you see this carefully, 2 last digit has to be divisible by 2, which makes it an even number. 4 last 2 digit has to be divisible by 4. We just did here. Last 2 digit has to be divisible by 4. For 8, the last 3 digit has to be divisible by 8. So 2, 4, 8, you can understand in a certain pattern. Okay. 9 also, the sum of digit divisible by 9. Okay, so for 3, sum of digit has to be divisible by 3. 9, sum of digit has to be divisible by 9. Okay, 10, you know, it has to be last digit has to be 0. 11 is a very interesting case. 11. So before going to 11, what I want to tell is 2, 4, 8 is follow a certain pattern that we showed you. 3 and 9 follow a similar pattern. Sum of the digit has to be divisible by 3. 9 has to be sum of digit has to be divisible by 9. So this is something you can remember. So this is one set of rules. This is another set of rules. 6 has to be a mix of 2 and 3. 5 and 10, you know. And last digit has to be 5 or 0 or only 0 respectively. Now comes the most interesting piece. What we'll do is 11 first. So for 11, first I'll write sum of digits in odd place minus sum of digits in even place is to be equal to 0 or multiple of 11. What I mean by that? So let's say there is a number 1, 2, 3, 4, 5. Okay. What are the sum of digits in odd place? First place, third place, fifth place. Sum of digits in even place, second place, fourth place. Okay. So sum of digits in odd place is 1 plus 3 plus 5. Sum of digits in even place is 2 plus 4. So the number is 9 minus 6, 3. So 3 is not by 11. So not divisible by 11. So this whole number is not going to be divisible by 11. Okay. The whole number is not going to be divisible by 11. But take another number. Let's say 1, 2, 2, 1. This is a number. What are the digits in the odd place? Sum of digits in the odd place 3. Sum of digit in even place is also 3. So 3 minus 3 is 0. So this number will be divisible by 11. So this is a very, very important problem. So let's say, I'll give you an example. Let's say 1, 2, x, 5, 7. So this is a number. But they say this number is divisible by 11. Find x. So sum of digits in odd place will be 7 plus x plus 1. So 7 plus x plus 1 minus sum of digits in even place minus 2 plus 5. Okay. So this is basically 8 plus x minus 7, or this has to be equal to 1 plus x. Okay. I just took a random number. So this is 1 plus x. Right. Now, to be divisible by 11, it has to be 0 or multiple of 11, right? In order to be 0, 1 plus x is 0. That means x is minus 1. Now that is not possible because no digit cannot be negative. To be a multiple of 11, the lowest value is only 11. So x has to be 10. Now a digit cannot be a 2-digit number. So this is also not possible. So x does not exist. Okay. So you got that approach. So you can find this type of problem and you have to apply this logic. So there are only two possibility when a number is divisible by 11. If the sum of the digits in the odd place minus sum of the digits in the even place is 0 or multiple of 11. In this case, x cannot satisfy either of this. X does not exist. Okay. Let's move to the next part. For 7, 13, and 17. So there is a particular type of rule. So let's say there is a number 357, for example. Okay. For 7, what we will do, we'll take the last digit out. We'll take the last digit and multiply with 5. So 35 plus 5 into 7. So 35 plus 35, it is 70. Okay. So 70 is divisible by 7. You see the number is divisible by 7. Okay. So for 7, You take the 7, you take the last digit and multiply by 4, multiply by 5 and add back to the rest. So if I take, so basically 3 from 357, I take 7, I multiply with 5 into 7 and add back to the rest, that is 35. Okay. For example, I take another example. For example, you take 1723 as a number. Okay. So what I will do, I will do 172 plus 3 into 5. So that is 187. I'm not sure on 187. So I'll do again 18 plus 5 into 7. So 35 plus 53. I know 53 is not divisible by 7. So then 1723 is also not divisible by 7. So you take this last digit out, you put it in 5, and then again take the last digit out, multiply with 5 and add back. Okay. So that's how you do it. Now, for 13, it's the same approach, but instead of 5, your number becomes 4. So 35 plus 4 into 7. So 35 plus 28, 55, 63. 63 is not divisible by 13, so this is not divisible. You will do the same approach. So the multiplication factor here will be 4. And for 19, sorry, this is 7, 13, 19. 17 does not have any rule. So this is for 19. For 19, the rule is 35 plus 2 into 7. This multiplication factor is 2. So multiply, this is 49. 49 not divisible by, so not divisible. Okay. So that's the rule that you need to see. For 7, it's the same approach. Multiply by 5, last digit, and keep adding back. For 13, last digit take out, multiply by 4, keep adding back. For 19, last digit take out, multiply by 2, keep adding back. And you continue that process, basically, till you get a number which you are confident on saying whether divisible by 7, 13, or 19. Okay, so that's the approach. Now let's take a problem. Let's take a number 1, 2, 3, 4, 2, 3, 4, 5, and 3, 4, 5, 6. Is it divisible by 12? Is it divisible by 12? So if you take this number, a number to be divisible by 12, it has to be divisible by 3 and 4. Now, if I just take 3, 4, 5, 6, if I just take 3, 4, 5, 6, the sum of the digit is 3 plus 4 plus 5 plus 6. So 7 plus 5, 12, 18. So this is divisible by 3. And 56 as a number is divisible by 4. Divisible by 4. So 4 is also checked. So if 3, 4, 5, 6 as a number is divisible by 3 and 4, so can I say 3, 4, 5, 6 is divisible by 12? So if you have multiplication of 3 numbers, out of that one number is divisible by 12, then the number itself will be, all the numbers will, the whole multiplication will be divisible by 12. Okay. Now let's tweak this problem a little. And let's say you have 1, 2, 3, 4, 2, 3, 4, 5, 3, 3, 4, 5. Is this divisible by 12? So for this, what you have to do is you have to divide 1, 2, and this is a homework. Try at home and give me the answer. So what you have to do, I'm telling you, you have to take 1, 2, 3, 4, divide by 12. The remainder you get, let's say the remainder you get from the first one is R1. Then you get 2, 3, 4, 5 divide by 12, you will get a remainder because it's not completely divisible. Remainder you get are 2. 3, 3, 4, 5, again you divide by 12, the remainder you get is R3. Multiply these 3 remainder and check what value you get. If that value is divisible by 12, the number will be divisible by 12. So check that approach at home and see if R1 or 2 or 3 is divisible by 12 or not. Okay, so this is a very good problem you can try at home. But I hope the overall session is useful. We understand the divisibility rule of different digits. Few important rules like 7, 13, and 19. We understand the very important rule of 11. And then 2, 4, 8 has a similar rule. 3 and 9 has a similar kind of a rule. So that we understood. We also understood what are the prime numbers, how to check the prime numbers. And we also understood what are the different classification of numbers, starting from rational, real, rational, integer, whole, natural numbers, all that approach. So this first session of number system is very useful for you. Please drop a comment if some part is not easily understandable or you need a re-explanation. We'll be able to help you. You can drop a mail in the mail ID given in the description box. Please like, share, subscribe for the algorithm, and see you next time in the next session of number system. Have a good day.